We're moving on to the next section of practice problems, which is on quadratic equations. So let's begin. Looks like question wanted to refer to this graph, and it tells us x squared minus 6x plus 5. Graph of quadratic is shown, okay? Number one, which of the following is the equivalent form of the equation of the graph shown above, from which the coordinates of vertex v can be identified as constants in the equation. So go ahead and try this one first. So here, if you remember vertex form of parabolas, it's like y equals a times x minus h squared plus k, where h comma k is your vertex. So what's the vertex here? The vertex for parabolas is the max or the min. Technically, it's the point of symmetry, but for parabolas and absolute value functions, it's easy to remember as the max or the min. So what's this point over here? That is 3 comma minus 4. So this is my h, this is my k. So it should be in that form, which looks like it's d. Okay? That's one way to do it. If you want to solve this algebraically, you would have to complete the square. Okay? And these clearly are not vertex form. These are factored form, which is good to get the zeros of the function, the x-intercepts of the function, which we can tell right away. It should be, in fact, we can factor this algebraically, actually. It will be x minus 1, x minus 5. So that would be this one. But then, as I just said, it's not getting the vertex. It's easy to get the zeros of the function. All right, number 2. Which of the following is the equivalent form of the equation that... Okay, so this is asking for the x-intercept. I just gave the answer. It should be x minus 1, x minus 5. It should be A. Okay. All right. Number 3. And the xy plane above, parabola, this is vertex form, it looks like, without the plus k, has one x-intercept at 4 comma 0. If the y-intercept of the parabola is 9, what is the value of A? Okay, so go ahead and try this first. So notice when I said, so this is the vertex form I wrote over here. The vertex is 4 comma 0. So the k should be 0, which matches what is there. So it should be y equals a times x minus 4 squared. And to tell us if the y-intercept is 9, so when x is 0, y is 9. That's the point. So we can plug it into our equation. 9 is equal to a times 0 minus 4 squared. So a would be 9 over 16. Okay? This is 9. That's the answer. Simple as that. In the xy plane, if the parabola with equation, this guy passes through 1 comma 3, what is the value of A? We can just do exactly what we did. We can plug in the point into this equation and solve for the unknown. So 3 is equal to A, 1 plus 2 squared, minus 15. Add 15 on both sides, that's 18. This is 3 squared is 9, so 9A. So A is equal to 2. Okay, you should be quick. The graph of the equation y equals a times x minus 1, x plus 5 is a parabola with vertex h comma k. If the minimum value of y is negative 12, what is the value of a? So go ahead and try this one first. So, as I was saying earlier, parabolas, the vertex is either the max or the min. And it's the absolute maximum, or in the calculus, you might learn it as like global maximum. So just introducing that terminology now. Global meaning it's everywhere. It's the maximum everywhere for all values of x in the domain. So, what was I saying? It's a minimum, so it's going to open upward, we know. Okay? Because if the parabola opens upward, then you have a minimum. If it opens downward, then you have a maximum. Okay? So we know that A must be positive, which I believe on the ST you can only have positive values anyway, so that makes sense. All right? Because you can't, at least in the traditional test, you can't bubble in a negative number if I remember correctly. Now, okay, so we have to remember, this is how I'm thinking of it. As I was saying, vertex is the point of symmetry. Okay, so to the left of this vertex is symmetric to the right. So if you can imagine if we fold it, it's symmetric, right? So the vertex is that center of symmetry, kind of. The point of symmetry. The axis of symmetry. That's the word I'm looking for. Axis of symmetry. Okay? So notice that even in this example, if we have the two x-intercepts, the vertex must be in between, right? Smack dab in the middle. Okay? And we can mathematically find the x-coordinate by averaging two x-intercepts. X-intercept 1, x-intercept 5, so 5 plus 1, which is 6, divided by 2, that's 3. That we average it. So, if we know the x-intercepts here, which are, that's 1 comma 0 and minus 5 comma 0. So the vertex would be, well, they gave us the y value as minus 12, okay? Then we just average these two. 1 minus 5, that's negative 4, divided by 2, that's negative 2. So I found what the vertex is right away. So this is the vertex. Now we can do what we did up here. We have the x and y value. We have the equation. We can find a. Okay? So it would be minus 12 is minus 2. That's a minus 2 minus 1 minus 2 plus 5. We're finding a. Okay, and then x is minus 2, not a is minus 2. Okay, so minus 12 equals a times minus 3 times 3. Okay, so a would be 4/3, it looks like. Let me check that's correct. Yeah, that's right. And as I was saying, on the SAT, at least in the exams in the past, you can only have a positive value for these free response. So makes sense that's positive. All right. So that's it for this problem set. So the key points looks like were vertex form. Vertex is the min or the max. And it's also the axis of symmetry, the point of symmetry. Whatever we call it. I don't remember the term right now, honestly. But you have vertex form, you have factored form, which is nice for getting the x-intercepts. And here the concept was vertex is in the middle of the x-intercepts, because again, vertex gives us the symmetric point, the axis of symmetry. Okay, so hopefully this is helpful. Those are the key points it looks like. Again, please study those if you're not familiar with them, and do more practice problems that you can find to get better at them as well if you are struggling with this set. Okay, so as always, please like and subscribe if you found this helpful, and please look out for the next video.